Have you ever really looked inside an airplane cockpit? When you pay attention to the pilot controls, you'll notice something interesting. Some cockpits have a steering wheel-like control, while others use a joystick-style stick on the side. So the natural question is, why do aircraft that fly in the same sky use completely different control designs? Today, we're going to break that down step by step in a simple way. Once you understand this, you'll start to see how much engineering thinking goes into aviation design. First, let's understand what cockpit control systems actually do. When an aircraft flies, the pilot controls three main motions: pitch, moving the nose up or down, roll, tilting the aircraft left or right, and yaw, turning the nose sideways. The cockpit controls act as the interface between the pilot and the aircraft. The pilot's hand movements are translated into movements of control surfaces like elevators and ailerons. Because of that, the design of the controls strongly influences how the pilot feels the aircraft and how precisely it can be handled. Now let's talk about the traditional system, the yoke. A yoke is a dual-hand control that looks similar to a steering wheel. When the pilot pushes the yoke forward, the aircraft nose goes down. Pulling it back raises the nose. Turning it left or right rolls the aircraft. This design has been used for decades and is a proven concept in aviation history. Mechanical linkages carry the pilot's input directly to the control surfaces, allowing the pilot to physically feel the aircraft's behavior. During turbulence, resistance and motion are transmitted through the controls, giving tactile feedback that helps with intuitive flying. This philosophy emphasizes a strong physical connection between pilot and machine. You can clearly see this yoke system in aircraft designed by Boeing. For example, the cockpit of the Boeing 737 provides pilots with a familiar, mechanical flying experience. Boeing's long-standing design philosophy focuses on maintaining pilot authority and direct aircraft feel. As a result, the yoke system aligns well with reliability, predictability, and continuity in pilot training. Now let's move to the modern approach, the side stick. A side stick is a compact joystick-like control mounted beside the pilot's seat. The motion principles are similar. Push and pull control pitch, while left and right movements control roll. The difference is that instead of mechanical linkages, pilot inputs are sent electronically to onboard computers. Those computers then command the aircraft's control surfaces. This technology is known as fly-by-wire. One of the biggest advantages of fly-by-wire is computer-assisted stability. Safety logic known as envelope protection prevents the aircraft from exceeding safe limits. Pilot inputs are smoothed and optimized. Cockpit layouts become cleaner, space is saved, and pilot seating is more ergonomic. This modern control philosophy is widely used in aircraft produced by Airbus. For example, cockpits in the Airbus A320 and Airbus A350 use side-stick systems that reduce pilot workload while adding an automated protection layer. An important point here is that yoke versus side-stick is not about which system is better. It represents a difference in design philosophy. A yoke emphasizes direct mechanical feedback and pilot feel. A side-stick blends pilot input with computer intelligence to create a smoother, protected control environment. From a training perspective, both systems enable safe flying through structured procedures and discipline. Human factors engineering also plays a major role in cockpit design. Engineers consider pilot fatigue, reach, posture, and workload when designing controls. Side-stick layouts improve cockpit visibility and keep instrument panels unobstructed. Yoke layouts provide stable dual-hand control. Both systems are the result of decades of operational refinement. In the end, even though aircraft controls may differ, the principles of flight remain the same: lift, balance, and coordinated movement. Safe flight comes from the combination of pilot skill, training, and system understanding. The type of cockpit control simply reflects an engineering evolution and design choice. Aviation is an ecosystem where technology, human judgment, and precision work together. Whether it's a yoke or a side stick, both are designed with the same goal: predictable, stable, and safe flight. The next time you see a cockpit photo or an aviation video, take a moment to notice the controls and think about the design philosophy behind them. That's part of what makes aviation fascinating. The same physics, approached through different engineering solutions. Hopefully, this explanation gave you a clear and deeper understanding of cockpit control systems.